parallel with DynamoDB. Okay, but technically DynamoDB is one of the service of AWS that is about the database. Okay, so what DynamoDB will do for you, let me explain to you. Okay, what DynamoDB can do for you. So it is something like this. If you talk about your typical traditional kind of databases, typically known as RDBMS kind of, maybe, or I can say SQL kind of, or maybe you can say your traditional kind of databases. Okay, they are good, no doubt, but we are facing some kind of challenge over there. So if I open my Excel sheet here and try to explain you what I'm talking about. Okay, so in your I can say in your traditional RDBMS kind of databases or SQL kind of databases, we have to first plan it. What kind of data we have to store? So I want to store name, I want to store email ID, I want to store phone number, I want to store remarks. We have to plan it. After we plan, and let's say we are going to create this kind of and these much columns, okay, or these much field. Okay, after plan is done, then we create a table. And the table we have to create these columns. So technically this kind of planning, right, we have to do first. Sorry, before we put any data. Okay, that kind of planning is known as schema. So technically first we have to create a schema, right? Or maybe you can think as a table we have to create. And table is something like this, that in this table in the future we are going to have only 4 columns with this name or this columns. So we have to create a schema first, then only after this we can start putting our data. After this we can start putting data, maybe name, maybe let's say Vimal, this is email, this is phone number, this is a remark, something like this. So we can start putting lots of data here. This is called a row, or maybe record, or maybe tuple, whatever we say here. Okay, so guys, if you talk about your traditional databases, okay, or I can say RDBMS kind of databases, it's just, for example, Oracle or maybe MySQL, right? So we have to first create a plan or a schema. Then only, guys, we can start storing the data. Okay, but in the future, let's say you have plan, when somebody say, no, I have I have 2 mobile numbers. Okay, but here, because we have planned to store mobile, or maybe somebody say, I don't have a mobile number, I have a landline number. Somebody say, I don't have a mobile landline number, I maybe have some kind of fax number, maybe. Okay, so what I'm trying to tell you guys here is, okay, if you start collecting the information in the future, what you will find, you find that the way you plan, that what information you want to collect is not available everywhere. Okay, so maybe one of the information you collect, let's say about Harry, and ask Harry, do you have the mobile number? And they say, no, I don't carry a mobile number, but I have the landline number. Okay, but if you ask the Bimal, do you have the mobile number? Yes, say yes, I have the mobile number, but I don't have a landline number. Okay, maybe somebody, guys, you go and ask, do you have email ID? They say yes, we have 3 email ID. This is email ID 1, this is email ID 2, email ID 3 for multiple purpose. Okay, somebody has 3 emails, somebody has only 1 email, somebody has no email. So technically, what I'm trying to tell you guys here is, creating a pre-plan or schema might not be the we can't do it before. That's what I'm talking about. And especially in today's world, the everybody has a different facility, different things, different way to communicate, different kind of information. So if I am a company, and my plan is to gather the information or to collect the information. I can't go for planned schema. Rather than what can we do? Okay, rather than what can we do? We can either add all the columns here. And guys, if we start putting all the columns, there might be thousands of columns gonna come up where everybody has different kind of information to share with you. Okay, so as a company, you want to gather the information about a customer, about your employees, or whatever the case would be. Everybody has a different information to share with you. Okay, so as such, we can't create a pre-created columns, or I can say schema here. Okay, or if you somehow created, okay, maybe you created as thousands of column here, and if you start collecting information, let's say from from Tom might have one email ID, might have mobile number. That's all. That's the only information Tom has with you. Okay, so technically all other field would be null. So finally, you know what? Finally, if you have creating this kind of Excel sheet here, or maybe you create some kind of database in your world, okay, what you will see finally, you see lots of field is become empty. Maybe you can say 0 is null. Okay, so but why I create a lot of field? Because I don't know what kind of information my customer gonna provide. So I should have all the possible field names. But if you do so, you can collect the information what customer will provide to you, because I don't want to lose the information from the customer, because today's world is running because of the data. Okay, data is a very critical thing. So I don't want to miss any of the information. But if you put all this field name, first of all, is very impossible. We don't know what kind of information the customer has. Plus somehow if you do so, then finally your sheet or your Excel sheet here, you can think this sheet is also one kind of database. Come with lots of null, lot of zeros. So there's a value here, but it's like null or 0. So unwanted, they consume lots of space in your RAM, a lot of space in your hard disk. Typically, guys, in our world of data, it's called sparse. So we have a sparse data. Means a lot of null and a lot of zeros we have. And sparse data is not good because they consume a lot of extra space. Because this guy has only 2 information to store. Let's say one information is 1 byte, for example, only 2 byte we require, for example. But unwanted thousands of extra byte they are going to waste and use. So what can we do? We can go for better plan to gathering the data and also to storing the data. Because guys, only gathering is not enough. After gather also we have to store somewhere in our storage. Okay, so what can we do? We can go for better plan. We can go for some kind of dynamic plan. It means let's don't plan initially. Let's go schema-less. Means no plan. So it's something like this. If I open one more sheet here, it's something like this. I meet to first of my employee or one of my customers, say, just share your information, what information you want to share with us. So say I have the name, I have this mobile number to share with. So let's the customer name check, this mobile number to share. Okay. Now next customer come up and we ask what information you want to share. So they say again, I have the name, I don't have a mobile number, but I have the landline number to share with you. So again, I have to add one more extra column over here, landline, and I'll add their landline number. Next customer come up, maybe this guy has a yes, they have both the things, landline number and the mobile number. Next customer come up, pop, both the things don't have, he have email address. So I will add dynamically one more new column name, a field name, and I store this email ID over here. Something like this. Okay, so technically what I'm talking about, rather we go and plan for pre-planned schema. That is also sometimes you can think, create your own table. We can go for this dynamic planning, where as soon as the customer start providing the information, we keep on adding the new column. and keep on storing the information. But it look like again the same kind of sheet. Again, we have lots of null here. This was sparse data. That's not good. Unwanted, they're consuming this piece. So guys, maybe it look like this. It look like this, but internally, internally in your hard disk and storage, data is stored in something like this. So if I write over here, so data store something like this. So I first collect the name. Let's say my name is Jack. What information you have? They have a mobile number. Mobile number, let's say this one. Do you have anything else to add? Right now, Jack said, no, I don't have anything else. So this is the only information I have. Okay, so what I do, guys, I create a separate, seat for this, a separate block for this guy, and say this guy has only one single information. What I mean by this in a minute, I'll just again explain to you. Then made with one more guy, and because this is a new customer I have, I create one extra block here. And what information you have? They say I have a name called Tom. I have the mobile number. I have the landline number. Okay. Plus that's all. Right now only 3 information I have. So technically, by visual, you can think it look like this, but it doesn't mean they have a null value here or 0 number here or null here. Okay, internally we are just storing these much information in our hard disk or in our only these much information, where every block is equals to one information, one record. Okay, and sometimes, guys, in this world, this one block is also known as one document. So this is my first document. This is my second document where I'm storing my information in variable and the value. This is called key and value. Okay, so if you store your data in key value pair, why you do so? Because in the future, I don't know what information Jack will have in the future they share with us. Maybe they have said, I have one more mobile number, comma. Okay, and use this mobile number. So take first mobile number as my primary mobile number, use this as secondary mobile number if I'm not able to communicate it. Something like this. So I don't have to go and add this field for everyone. Everyone. Only those guys who have a secondary mobile number, I just go and add this key with the value and this one. And then I can say this is the one entire document create for Jack. This entire document create for the Tom. Something like this. So this is the concept of schema less. As the demand come, okay, or as the information keep on coming, initially we gather all the information of that particular customer or the employee. Or maybe in the future, they want to change the landline. For example, Tom says, I want to change my landline. So I just go and check, does they have the key called landline? Yes, we go and change. They say, I want to add one extra field called remarks. Maybe let's say, okay. So it's very dynamic. Every document is a one information on one record. They can treat it separate. So finally, what I'm talking about, because we don't know what kind of information my customer gonna share with us. I don't want to lose any information. But I don't also want to create my pre-planned schemas or my column names. Mostly we don't know what's gonna come up. So better plan for storing the data, or better plan is to create this kind of model. This is not a data model, where every information I store in a separate block, and this block is normally known as document. And this way of storing the information, okay, is known as document oriented database. Okay, where we have no schema, is schema less. It's something like this. Schema less. Okay. So what's the benefit? I think, guys, you understand the benefit is we have to save the time, plus have to collect as much as information about the customer, and everybody has a separate record format. So this is my record number 1. This is my row number one. Sometimes this is also known as one document. So either you can use the word document or the record or the row. It is the same thing over here. Okay, this is one thing. Now, second thing, guys, over here is okay. If you talk about, if you want to store this information, I just some guys just giving this information in this format, or just to explain to you. But you want to store this information in your storage, in your hard disk. There we require databases. I guess a lot of database software available in the market that has a capability of document oriented, where every record is one document. One of the good example of document oriented is MongoDB. If you guys was with me in my MongoDB training, similar kind of concept in more detail I cover there. Okay, but today's plan is not MongoDB. Okay, we are going to use one of the service that is provided by AWS. That's called DynamoDB. Okay, so what is DynamoDB? Again, it is a database only created by AWS. Okay, interesting thing about DynamoDB is a database like MongoDB. Okay, but it is serverless. What is serverless? You guys know. Well, I will explain you very quickly also one more time. As serverless. Okay, so we'll talk about this, but technically, that's right now the focus area would be, if you talk about DynamoDB, they are document-oriented database where all the values stored in key value pair. So I can say this is document-oriented database where we store the data in key value pair. Okay, so there's very quick information about DynamoDB. Okay, but let's forget about serverless for a minute. And if you want to create a database, right, how normally we create. So it's something like this. And guys, again, I just want to repeat, I'm also taking a Cassandra also in parallel, because the architecture that I'm going to explain you right now, Cassandra also work in the same architecture. Okay, what I mean by this, I will note, make a note when I try to explain you the difference, why I'm taking the Cassandra also parallel. Main topic for today is obviously DynamoDB, but you come to know, guys, why I'm taking Cassandra also in parallel. Okay, but one more point I want to add here very quickly. Okay, if you go for this kind of planned way, schema way, they are normally known as SQL world, but there's no plan. Okay, as the things just keep on coming, you start storing, but obviously in some kind of managed way. So that I said this is the one extra information, the second record I have in some kind of managed way. Then this kind of database is normally considered as a NoSQL. Means not only SQL. So they're not only SQL. What SQL can do, they can do for you, but they can do some extra thing for you. So DynamoDB, Cassandra, MongoDB, Redis, those are normally come under the category of NoSQL databases world. Okay, so very quick information. Let me go more in deep about this topic. Okay, so guys, today's topic is database. Very quickly, if you want to explain you what database is, the way to store the information. So information is normally known as data. And guys, if you want to make data store permanent, we always store data in a storage. But if you want to store data, we always need a file, and file we always store in a folder that you guys know. But in the database world, this folder is normally known as database. In database world, the file is normally known as table. Or in the file, whatever extra information is stored, or whatever information you store, per information about one customer or one employee are normally known as row or maybe record. But here they normally known as document. So this is my first row or first record or first document. So this is the term normally we use. Okay. So, but technically, finally, the main point here to highlight here is, if you want to create a database, okay, you need a storage. Okay, let's from here, guys. Let's start the thing. The second thing is, if you want to create a database, you need some kind of software, some kind of program, depend what kind of database software you want to use. You want to use SQL world kind of software or no SQL world kind of software, depend on the requirement. So the SQL, let's say MySQL, MariaDB, Postgres, SQL come up. In NoSQL, we have MongoDB, Cassandra, and something like this come up. Okay, so depending upon requirement to requirement, we need either this software or this software. After with this software, we have a database server. Okay, but what database server need? They need data to store, and for data to store, we need a storage. Okay, this is a very quick, information over here. I think most of you guys already know this. What I'm trying to explain to you, just want to sync with you. The main key here is storage. Why I'm saying is main key, let me explain you what I'm talking about. So technically, if you talk about the storage is a hard disk. Guys, this we have already discussed about the storage multiple times. Okay, in the storage, guys, let's say this is your hard disk. Okay, and all the hard disks in the market come with their own speed. This normally known as throughput. Means how much data you can store per second basis, or how much data you can read per second basis, called IOPS or IO, input output operations, that I already explained to you guys in some of my class. So guys, depend upon the hard disk speed, we have a limit. So let's say my data is coming, let's say they're coming 100 MB per second. This is my internet speed. But my hard disk speed is 10 MB per second. Means that much speed they can write on the hard disk. So what happened, guys? Obviously, my data is coming 100. They can write only 10. So what happened with 90% data? Either they terminated, they won't store, or maybe there's some other extra mechanism in our computers world. If the speed of my hard is slow, so they will tell to our network guys, my network bandwidth, and say, please go slow down your speed because my hard disk have no that much speed. Okay, so there's concept called windowing. If you know about network, we have a window concept. Okay, so there's a different concept of network, but they help us to slow down our speed. Okay, so this different concept. But technically, if your hard disk is less, it will slow down everything. Maybe network, maybe RAM also storing the data from the RAM to hard disk. Everything becomes slow down. So hard disk is normally, guys, the bottleneck we have. Okay, bottleneck in our entire infrastructure. Okay, why I'm saying this? Because if you talk about a database and database finds storing the data in the hard disk, but there might possibility that you are getting a data and it's information with very high speed. Okay, the high speed you want to write, or maybe the high speed you want to read. Let's say maybe data is coming from some kind of IoT devices. So we have a lot of IoT sensor across the world. They are collecting the data of temperature or weather from vehicle, IoT based devices. They're collecting the information, and the huge information they are collecting from different IoT devices. Okay, and we are storing those information in database, and they are storing over here. Or maybe let's say they're collecting all the information with the speed of, let's say 100 MB data come per second, but my hard disk speed is 10 MB per second, for example. So what happened? Obviously, these guys are maybe they're collecting the current temperature, current environment information. Maybe these IoT devices is assembled in my vehicle of some car. We are collecting the information and storing somewhere. Here, guys, we can't slow down. We can't slow down. We can't say just just slow down the speed with 10 because they're collecting every second. Okay, how can I slow down? Because every second they collect, every second they send to us. Okay, because it's a real time. Okay, and I want as soon as they collect, I want to store somewhere, otherwise they lose the information. So in this case, one of the possibility would be I can take a hard disk with some better speed of IO or IOPS maybe, okay, or throughput that I already explained to you. But let's say we have some limit. What are the best hard disks you go? There's some limit that you can reach. After this limit, you can't go beyond that much of read and write capacity. So either you can increase your capacity of read and write. Okay. So guys, in the DynamoDB world, that's called WCU or RCU, write capacity unit, read capacity unit. In DynamoDB world, there's a term you use, but it's a very common term. The DynamoDB, they use this term WCU and RCU. Okay, but the point, guys, here is either you increase your read and write capacity, but there's a limit, right? You can't go beyond that limit. There's a limit of read and write upon is based purely on how the hard disk has been manufactured. Okay, but other possibility would be we can go for better plan. Okay, one of plan we can go and create a cluster. We can go and create a cluster. What I mean by this? Okay, so what can we do? Rather than we use one single hard disk, and guys, obviously hard disk is taking the data from database, and for database we need operating system. Okay, so rather we create one single operating system where we store database server, and that system is currently one of the hard disks. Okay, so this entire setup is known as database server actually, or this entire setup is normally known as node. One minute, guys. Okay, node. We can create multiple nodes. Okay, this is node 1. Same, I can take one more OS, one more database, same software with again new hard disk. This is called node 2 and node 3. So multiple nodes we can connect together. And now what happened? We might have some kind of centralized program here who are going to manage this node, manage these nodes. And this program, guys, is normally known as master program or manager program. What is the use of the master? This is the same thing as we have discussed already multiple times. So this is called master. These are the worker node or the slave node. It's called master slave model. Everybody work together. It become a cluster. Okay. What is your role of master? Whenever any data come from any source, let's say from IoT devices, okay, first they reach to master. Not data reach to master. Okay, we send the instruction that data is coming. Okay, with this much data is coming. So master will take some decisions with some kind of rules and say, let's say out of 100 MB data, send 10 MB here, send 10 MB here, send 10 MB here. So we might have 10 different nodes. So distribute our data. And this concept is called database distribution or distributed cluster for database. Okay, so distribute our data in multiple node. What we will achieve? Okay, here data will flow with 10 Mbps, 10 Mbps, 10 Mbps, and 10 Mbps. Okay, and hard disk speed is 10 Mbps. So every second data come up 100 Mbps. So all those 10 guys work together and collect the entire data. So we don't lose the data, we don't slow down the data. If more data come up, more node we can add. So technically what I'm talking about, if data is coming in your computer with some speed and store the data in the database. One of the approach would be we can increase our read and write capacity. This is called throughput, right? It is only possible if we have a that much speed of hard disk is available. This is called write capacity and read capacity. This is one of the things we can do, but it is per node basis or per hard disk basis. Okay, but obviously if you go for more write capacity, faster you can write. If you go for more read capacity, faster you can read. From where you get this? With better hard disk, with better IOPS, with better throughput. Obviously they come with more in price. Okay, this is one of the approach we can use, or we can use this approach where we can create a distributed database cluster where my data is distributed across the cluster, or we can use both the approach. I can go for distributed database cluster plus my hard disk also. We can maybe initially, guys, we can go for 10 node cluster. Okay, but in the future, if data keep on coming, increasing, we can increase my write capacity or my read capacity. We can increase in the future whenever we need, or we can decrease if we don't need. Okay, and how to increase, decrease? Obviously, you have to change my hard disk. If I need more speed come up, we just remove the hard disk, add the hard disk, or maybe something like this. But technically, what I'm talking about, guys, if you see this setup, we have to set up 10 different node, one master, connect each other, or as per the requirement, we increase and decrease my hard disk speed. Maybe technically, practically, you have to change this hard disk. That is not practically possible. Okay. So a lot of setup, guys, you have to do if you want to set up this kind of environment. Okay, so either you set up this environment by yourself, or their use of serverless gonna come in. So I'm going to say there's a lot of requirement for this. For this, so I come with my own service or database service that is created by me. There's not third-party service. That is service I have created, which AWS guys has created. Okay, the serverless means you don't have to worry about any master computer or any slave computer. Okay, it's pure serverless. So I will set up the entire serverless for you. But interesting thing here is you don't have to tell how many nodes you need. Okay, you don't have to tell which master you need, which version you need. Everything is seamless or serverless. Okay, finally, what you need? You have to create is store this data. You store this data, and where you store this data, you store data in Seed. Seed is, guys, over. You can think also like a table. Just come to me and create a table. That's all, and start putting your data. Okay, start putting data. I will automatically create a master node and worker node for you. I automatically add hard disk for you. If your data speed of incoming increase, so I automatically increase your write capacity. If you're reading more and more data with a speedily, I automatically increase your read capacity. Okay, so all the scaling part or auto scaling part in all the form I will do for you. Even though normally in the database you have to create a database also, so you don't have to create any database. Just directly create a table and start storing your data. Okay, and I will show you data in the schema-less way. So first record, you need some other information. Next record, you need some other information. I will do for you. So DynamoDB say I'm a document-oriented, okay, key value pair database. And here in AWS world, we have provided you a distributed cluster behind this. That is just seamless, pure serverless. As the demand, I will increase and decrease the capacity for you. So you don't have to worry about, you have to just start storing it. And because this is the Amazon Internet Services, we are also using all the best practice of security, backups, and other management. For example, okay, initially I will give you, for example, if you're launching in Mumbai region, in Mumbai we have 3 data centers. We got 3 AGs, 1A, 1B, and 1C. So internally, when you store any data, I will create three nodes. One node is 1A, one node is 1B, one node is 1C. Okay, for you. So we store any data. Okay, let's say you store this data, name equals to Jack. So what I will do seamlessly, I will store name equals to Jack here. Same copy I will store here. Same copy I will store here. Why? Because you guys know, because of high availability. If this data center goes off, this also goes off. We have data still available here. Okay, so we go for multi-AZ by default for you, and we store all the your same data in multiple different data center. And this concept is called also known as replica. So we create a replica, multiple replica. So you have three regions. So I create three copy for you behind the scene for you. So I will manage the replica of your data. And why we need replica? We need replica, guys, for two reasons. One, for fail over. If something goes down, my data is still available. This is the one of the need of replica. Other need of replica is to increase the speed of read. That I already explained, guys, if you remember in my RDS classes, but let me very quickly explain one more time. Okay, so for example, we have one node in 1A, one is 1B or 1C. Okay, so let's say this is three different node we have. Same data, Jack equals to name we have, name equals Jack we have, name equals Jack we have. And all three computers working. It doesn't matter they're working in the same region or different AGs or same region or same AG. That doesn't matter right now. So what I want, okay, if some of my team member looking for the data, so some of the team member will contact to this guy to read. Team 1, team 2 might contact to this guy to read. Team 3 might contact this guy to read. So what we're doing, we are distributing our read. So three team or maybe same team are reading for multiple locations. They have multiple different hard disks. So obviously your read speed will be double and triple and depend how many node you have further. Okay, so if you have a replica, guess some of the concepts are taking very faster because this concept I have already explained you some in some of my other classes in some way. So just want to compile every information here and try to tell you what DynamoDB will do for you. Okay, so because we have these three nodes, for example, so multiple different team will connect to different node and read, and they can read in parallel. Okay, so there's also, guys, extra benefit you have if you're a replica. So replica help you in high availability. Replica also help you to increase your read capacity. So more replica I have, more read capacity you will increase. Okay, and when I say team, I mean to say applications. So guys, normally your database is connected by your front end application or your server-side language like PHP, Python, something like this. So as such, we don't never go to read from the database. My front end or my back end server programming languages like Python or PHP or Ruby, they will go and read the data for us, or they will write the data for us. So they might be one application. So the application will provide that they have a three database running, same copy. Okay, or three endpoint we have. First go read from here, read from here, read from here. So there is pure further programming skills. Program will write those logics that read from here, read from here, or read from here. And something like this. Okay, we can hold for a second, please. So something like this. So technically, all the facility that I'm talking about right now is available in DynamoDB. So if I go and check AWS DynamoDB, okay, and if you check here, it is a document oriented database. Okay, is key value pair that I will explain to you. Mainly they create for at scale. If you're looking for millisecond performance, this means very quickly if you want to read, okay, they provide to you. It fully managed, means pure serverless for you. And everything, guys, is purely managed by this service. Okay, one of interesting part of DynamoDB is they can handle trillions of requests per day. I guess top big companies or social media companies, they need these kind of requests. For example, Lyft, Airbnb, these are the companies who are using DynamoDB like anything. Okay, so that's all. And the good use cases where IoT, gaming services, mobile services. Okay, these are some of the applications where you can use DynamoDB. Okay, but interesting thing is we don't have to manage. Entire thing is purely given a guarantee by the AWS. It's pure serverless. Okay, even though you never see a cluster running, so they create a distributed cluster for you. They put hard disk, OS, everything they do for you. Our duty is to just go and create a table and start storing the data. That's the only thing we have to do. Okay, so that's the main thing. But by this, there is some more thing we have to do. As I said, just to tune our DynamoDB the way I want. But main thing is to create a table and store the data. Now, there's one more thing, guys. I would like to add about the DynamoDB, how they store the data. Let's go data model. I will explain to you over here. They store something like this, not obviously in this kind of format. This look more like JSON, but they have their own internal binary format. But technically, it looks mostly like this, where every record is one document, individual document or individual record. So in the future, if you want to retrieve this record or want to search this record, how can you do? There might be possibility of one more name of a customer named Tom come up. Maybe have different mobile number, maybe same mobile number might be. So if you're looking for the Tom, how can you search? Let's say I'm looking for this Tom or this customer. For this, what we do, guys, while creating our document, we have to take some unique ID. Let's say 1. We give this one as a unique ID, let's say 2. And we give here unique ID, let's say 3. So every document we have to give some unique ID. So we identify these document with the ID. Typically, guys, in the database world, this kind of unique thing is known as primary key. So we have to provide some kind of primary key. Primary key. Okay, and obviously, guys, primary key should be unique per document basis. Now, it will be your choice. You want to make ID as a primary key, or because normally we know, guys, email ID is a very common thing that is always unique for every customer. Maybe Jack is something.com. Yeah, maybe email t@something.com. So it will be your choice based upon your data. What do you think? How your customer is uniquely identified with email ID, with some unique ID, employee ID, mobile number? That will be your choice. But if you want to use email as a primary key, that it should be compulsory. So you have to collect email for all the customers. Without giving the email, that information won't be stored. So what a primary key you store is again one kind of column name or field name. it should be compulsory. So if you think email would be a primary key that uniquely identify your data, so in the future, if I say I just search only for data that is j equals u.com, they can search for you. Okay, so they would be a unique thing for you, or you can this will be uniquely identify these information. So while collecting the information, if email is primary, so it is a compulsory field. If some customer say no, I don't have email, so we can't store this information. We can't store Jack here. We can't store Tommy. So you have to plan it. That will be your planning. That what you think, what would be your primary key, or whatever it should be, it will be collected by the customer. You know, sometimes guys we create account in some website. They normally ask email. It means they make it email compulsory. It means they make it email a primary key behind the scene. Okay, so that is the meaning of the primary key. So one key should be a primary key for us. Okay, now we have lots of more things to add here. There's called sort key, partition key, and something like this. We'll guys see in some minute. Let me first show you how to use DynamoDB. Okay, how to use DynamoDB. Then we'll talk about further concepts. So what I'm doing, I'm just logging to my AWS account to show you how to use this. You guys, I just stop sharing for 1 minute. Just give me 1 minute, please. So let's continue. Yeah. So so let me go to my AWS account and let me show you how we can use DynamoDB. So it's a plain serverless service. Just go and create a table and use it. So this is my AWS portal. Okay. And if you search for DynamoDB, it's a managed NoSQL database. Okay. So you can see here is DynamoDB fast, NoSQL, all the things they posted here. Okay. And guys, if you see here, there's not talking about any kind of distributed cluster to create and something like this. They're directly asking to create a table. That's all. They say underline whatever I discuss right now to you. This replicas, this cluster, distributed cluster, everything is going to managed by AWS. We'll just create a table. That's all. Give a table name. Okay, so let's say my plan is to store this information. So let me store this information called customer. Customer is my table name or file name or seat name here. If you talk about this perspective. Okay, so this is my entire table. And what is your primary key? That is compulsory. Okay, so let's say my primary key is email. So email would be my primary key. Okay, that's all. It means if you want to store any information, email is compulsory. Otherwise, whatever you want to store, that would be your choice. Okay, and they will go for default setting. Right here, they're talking about capacity. We'll talk about this in some minute. So let me go by this. So only two things I'm adding here: my table name and my primary key. What is person key? I will explain to you in some minute, but let me go to primary key. Great. So this guys, your table created internally. Internally, entire cluster they created for us. Database they create for us. Okay, everything what I explained to Replica, all the things setting they have done for us. You don't have to worry about it. And now in this table, how many data I have is called items also. So I have no item. So technically in DynamoDB world, right? Either you can use the word record, row, or document. Here we use the term called item. So how many items I have right now? No item. So in the table of customer, where email is compulsory field. Okay, if you search, I have no item. But let me store the item something like this. I have to store something like this. So how can you store? So there's a create item here. Email is compulsory. Let me use the email called, let's say jack@gmail.com. Okay. And let me add one more item here. That's called append. Right here, they also support data type. What kind of data you want to store? Number, map, list, boolean. Let me go for string one. And let me store name called Jack. I'm going to store one more information because I know the mobile number of Jack. That's one. And that's all. These three information store. But my same customer, if I go and start collecting, image again compulsory. Let's my next customer is Tom. Their email address I collected. But this customer guys don't have a mobile number. Instead of mobile number, they have the landline. Okay, they have the very different information altogether. They have maybe they have some remarks to store. So guys here, their information is very different. This information is very different. Everybody is storing a different information here. Okay, so it looked like this. This way, guys, I draw here. It looked more like this. But internally, they don't store in this format. Okay, they store in the format something like this in the key value. But technique just to show you the visual, it's so in something like this. Okay. So what is this? This is the sorry, one document. This is next document or next item, and every item guys has their own individual records to be stored. Okay, so if you want to search the entire data in this table, there's a keyword called scan. If you use scan, they will go and scan entire data for you and sort it. But normally, guys, we have a huge data. Okay, I don't want to see all the data here because billions of data. There's no meaning to retrieve entire data. So we can do one more thing here called query. But in the query, guys, we can go and search the thing. Okay, so let me search with the name of email. Let's say I know my email. Let's say T @ that's my primary key here. The unique ID. We'll type my email ID. Okay. Then I start searching. They search this particular. Okay, but let me do some more thing. Let me again go for scan. This entire data come up. Again, let me go to query. And what I'm looking for, I would like to add some filter here. Okay. So here I'm just trying to search with let's say landline equals to 444. So I'm searching landline equals to 444. Okay, and I'm not using any patterns. So start search, then nothing is happening. Okay. So what I'm talking about, right? if you search anything, providing a partition key is very compulsory. What I mean by this, let me add one more example here to explain you. So let me add one more details called, let's Vimal or v at gmail.com. Let me add one more information here. Let's call remark. Let's go okay. Okay, and save. So if I normal search, let's go scan. If we go and search entire data, let me remove this entire data. Okay, and now here, let's say you have a requirement. I want to search the entire data based on my remark. Okay. Okay, this is my plan. Okay, or let me add a better plan. We have a lot of customer guys. Just focus on this topic, what I'm talking about right now. Okay, so let's say I'm going to add one more email. Let's say a@something.com with string called, let's say, city. I'm adding a city called Mumbai, for example. One record created. Let me add one more record. Is b@lw.com something. And let me append. Guys, here also you can append, delete, and all the things you can do. Again, city. This is again Delhi. Let me add one more. Then I'll just explain what I'm talking about. c@lw.com and a string again city, again Mumbai. Okay, Mumbai. See. Let me guys edit this. We can also directly edit. Let's say my plan is something like this. I want to search all the customer whose city is Mumbai. Okay, this is my plan. So if I do here and add city and say I'm searching for Mumbai, okay, I'll just click here and guys, this will come up. Okay, this will come up. So nothing very technically. But if I go to query, okay, and let's say I will have to query some particular email ID. Okay, so you know what I'm talking about finally. Let me again go and search for a@lw.com. Okay, if I search, this will come up. The guy search for. Let me reframe my question, guys. My point to make you proper understand. Just let me reframe what I'm talking about. Just give me 1 minute. So what I'm technically wanted, I want looking and searching for the city that is a Mumbai. So pretty simple. I can add extra filter. Like in SQL, we have a where clause. Something like this I can do and say this guy has a field called Mumbai, or this guy has a information called Mumbai. These two come up. So nothing very much unique. So it's like a filter or like a where clause. All the information gonna come up. But you know what I'm talking about? Okay, this is a simple portal. They have where we can search the thing, scan the thing, query thing. Scan means go for all the data, search what I'm looking for. Okay, or query means just go to one particular document and search that particular document. Okay, so that let me again very quickly explain to you. So go to one particular document and search in this document. So there's a only quick difference. But what I'm trying to tell you guys here, okay, if you want to improve your performance further, right now we have very limited database here, and what I can say, AWS is providing a limited speed. That's called capacity. Because here they given a capacity called read capacity unit, and write is 5. But at one point in time, you can do 5 read and 5 write. Then you can increase. Let me go for 10. But if you increase, guys, that cost is also increased per month basis. Okay, Means, you guys can hold for 10 seconds, please. So that's what the thing I was talking about, right? Last in this example over here. Okay, this one. So you can increase your read and write. Obviously, guys, if you increase, they will give better IOPS, better throughput hard disk. They will charge you more. They will charge you more. Okay, but here you're doing provisioning manually, and say I want this much speed only. But there's option, guys, they provide you auto scaling, where you can say I don't know, I need 10 or more. I want, you will do read capacity and write capacity, you auto scale it. As my my target increased by 70%, it will happen. Okay, so increase my 1 unit, second unit, third unit. Maximum I want 40,000. But initial I want 5 units. So I think what a unit is something like this. Your speed, your throughput. Okay, so what is speed? How much you can read, how much you can write, one point in time in 1 second. That you can think this is unit. So either you can change the unit. Auto scaling. What is auto scaling? You guys know. Okay, we can give the minimum and the maximum. Yeah, something like this. In ASG, we have discussed minimum instance and a maximum instance, something like this. But your fixed budget, you don't go for or read and write. You just set it in the fixed that I want this much read and this much write speed. Okay, but I think in your free tier, 10 RCU or WCU is free in your free account. But let me go for 5, or maybe let's go 5. That's okay. But lesser you go, okay, lesser your price would be per month. Because internally, it is a game of storage. How much throughput storage they are going to provide to. So let me go for 2. Okay, save it. So now in this particular storage, or in this particular table, this is per table basis. So in this table, this much speed of read and write we are going to get. Right now is okay because we have very limited data. Now what I'm talking about here, here is finally, let me go for scan and search again. So what I'm talking about now, guys, technically, what Amazon will provide to guys now here, very important concept going to start. Let's try to focus on this concept. What Amazon is going to provide, they are creating a distributed cluster for you. They're creating a replica for you. Okay, and plus they are helping you provide a different storage with different IOPS, which is called RCU, means read capacity and write capacity. That's what they're providing to you. Okay, so we can utilize this power of AWS to improve our speed of reading and writing. Plus some maybe distributor we can use for high availability also. But but as a good database engineers, okay, we can do one more thing here to improve our speed, that we can properly organize our data the way I want. Okay, because just small organization of data will exponentially increase your speed of scanning or maybe query. And there is limited, but if you talk about billions of databases, okay, just small organization of your data in proper way while you store will exponentially increase your speed of scanning and searching of query. That's called data model. So if you have properly created your data model or data organizational part, you'll see suddenly you will get a speed like anything with this limited resource. Okay, how? So guys, it is all about your requirement. What is your final requirement? Okay, let's say you require something like this, because something like this, where what I want, let's say you are uh, blogger, you write articles, a blog in some website, and when you go and log into this particular application or website, you have to create an account that's called user. Let's say you create an account with the name called Vimal13, unique ID I created here, but obviously a username should be unique in the websites. So there's a unique ID we have created. Nobody has this ID. And in my account, I create multiple posts or multiple articles. So there's a post 1, post 2, post 3, post 4, and n number post I will create. Okay. Now what happened? This post contain what? Name of the post, title of the post, content of the post, when this post created, maybe some more extensions. Okay. What next post content? Again, the same information, maybe a little bit extra also. So technically, for the DynamoDB perspective, this would be, we can get, this would be one of the item. This would be one of the item. Okay. But in this item, the common thing is my user. Okay. So my Vimal13 would be the common thing about this post. Okay. So what can we do? Okay. What can we do here? We can tell our distributed cluster and say, I know we have a lot of node here. Okay. And what I want, let me take one more very quick example, then I come to this example. So this example will help us to understand what is short key. Before this, let me add one more concept here. It's called partition key. So for this, just try to take this way. For example, your customer 1, this customer is based on city called Mumbai. We have customer 2, this city is based on Mumbai again. Customer 3, this city is based on Delhi. Customer 4, this city is based from Bengaluru. This city is from India. Customer 5, this base again of Delhi. So what I'm talking about, let's say these are the lots of customer we collected. Okay, and obviously we get some more information about the customer. Okay, phone number, remark, mobile number, something like this. Okay, but I know our requirement. Our requirement is something like this. Okay, in the future, normally we have to group, all right, a customer based on cities, because the very common requirement, we have a different sales team and marketing team. All the customer who are Mumbai, we give this entire information to one of my sales team and say, you are handling this region Mumbai, take this lead and follow up. So technically, this guy had to only search and look for Mumbai data. Or this sales team member always search for Mumbai. They look for multiple different customer, and every customer has their own report. Next sales team member, we look for Delhi. They look different customers we have, and there are different records there. Okay, so what can we do? We can go do this kind of planning here. Okay, because we know my sales one, my team member always look for Mumbai. So what can we do while storing our database? We'll tell our DynamoDB and say, just allocate this particular node for Mumbai, this particular node for Delhi, this particular node for city called Bangalore. Okay, and all the Mumbai information. In my case here, my Mumbai info was C1 and C2. Okay, stored this information in the same node. In Delhi, let's say there's customer 4, in Bangalore, there's customer 3, customer 5. Okay, so what I'm asking here, because our requirement, because again, company to company requirement change, team to team requirement change. But here, our requirement is mostly work per city, per country, per team, per product wise. So I want store entire product information or city information in one particular node. Okay, in one particular node. Second thing, I also want okay all the customer information, because after my team looking for the Mumbai, what they see first, the customer name or the customer IDs or user ID or email ID. Okay, obviously in the Mumbai, this customer should have unique name, this should have unique name or maybe unique ID. So inside this, automatic maintain my customer information in the sorting order. Because you guys know, if your data is stored in sorted order already, then searching won't be big deal. So again, I'm repeating, guys. Anybody who know by chance linear search means your data is stored, let's say in order called, let's say A, then E, then Z, then F, then M, then I, then O. If I ask you to search for M, then because the data is not sorted, so I go to linear search, I go here, then here, then here, and here. It takes a lot of time for searching because data is not sorted. I have to go to all the items to search my final item. But data is ordered stored in the sorted way. Okay, something like this, like A, then B, then D, then F, then M, then Y, then Z, sorted order. That if I'm looking for something, I know data is sorted, I can directly go to the middle and say I'm looking for M. So I reach to F, obviously M will be in the right side. I go to M and I can do very quickly search. So anybody who know about searching concepts, this is called binary search, right? Because data is sorted, we can do binary search, they will do searching very much quickly. Okay, so what can I do? Okay, first of all, because we know our requirement is to search per city wise. So first we collect all the data from the Mumbai city and store this data in only one dedicated node in one place, I can say. Second thing, what I do, okay, inside this data, I know my unique thing here is customer name or customer IDs or email ID. I store already in, while storing, we store in sorting order. Because the point, guys, here is I have billions of data. In the future, if I read something, my speed would be very fast in reading also. So if data already stored in sorted order, reading would be very fast. Okay, and then after this, all the information about the customer I will store. C1 has name, remark, mobile number, landline, remark, product name, we store here. And guys, by the way, this information here, this information, name, remarks, landline, these are known as attributes. Attributes. But in this entire concept, okay, if you say this is the data set you have, where you store city equals to Mumbai, for example, customer ID equals to, let's say, 111. Okay, something like this. So these information you're storing here. Other guys also we're storing information for city, let's say Delhi. Okay, again, this is a customer, different customer with a different ID, obviously, let's say 222, something like this. And let me add one more customer here. That's called city. Again, we have the city. Let's say again Delhi, and again we are showing customer ID to uniquely identify a customer. That is a 330. Now what happened? Because this city and this city is both the Delhi, so this both the document I store in one single area, one single space, and that single space in area technically known as partition. So we are partitioning our data, grouping our data clustering our data city-wise. Then city would be the city would be known as partition. Why city? Because this is my requirement. Your requirement will be different. So you can organize your data in different format. Okay. And in this partition, I have a lot of data, customer to customer thing. So customer is a is a one attribute that uniquely identify my item. But I also want they stored in the sorted order, so I can search very quickly. That was one of my requirements. Searching should be very high, very speedily. So here my customer ID was known as short key. Short key. And all other information, let's say this information, would be known as attributes. Now these are 2 attributes, there are 4 attributes. Now because schema less, how many attributes you want to store, that will be your choice. But this way of planning is highly improve your performance. I can say exponentially improve your performance, because if anybody know about binary search, the search with the speed of logarithmic, and here the search with the speed of n. So n data you have n time that they have here you have n data with the speed of log, means exponentially you improve your speed if you know about the search algorithms. Okay, so anybody who are from Earth Learner in our DSA class, guys, we talk about this algorithm very detailed. You guys know this, but otherwise we don't have to know much about this. Just keep this in mind. Storing data is not enough. Way you store, all right, always matter a lot, because in the future we have to finally search the data and retrieve the data. Okay, so 2 things we are using here. One is partition key. So in the future, if some customer come up and they say, I want only looking for Delhi data, they don't have to go and read this data. They go to this node, only this much data they will search. So maybe have 100 cities, 100 GB data we have. So only 1 GB data we have here, 1 GB here, we have 1 GB. So now anybody looking for Delhi, we don't have to search on all the data. Only 10% data we have to search, because we know Delhi belongs to 10% data. In this 10% data, because we know my customer ID or customer name, because they are already in sorted order. So further searching speed would be again would be exponentially fast. Okay, so this kind of planning you can do. So so technically what I was talking about, okay, distributed replica IOs that has been provided by AWS. Guys, we give more price, they give you better speed, but in one single hardware, just having your proper data model, let's go organic data, will also exponentially increase the speed, especially I'm talking about read speed. Okay, so having a proper data model or proper planning is very important. And that is the reason, let me create a new table here. Let me give a table name called again customer 1 or customer data. And guys, here we have concept of partition key and sort key. So according to my plan, I can make city as my partition key. And I add and make customer ID or customer name would be my short key. Okay, customer ID is, normally is a number, so I make this guy as a number. And in this case, every customer, let's say this is a customer. Now this is identified by city plus customer ID. These 2 information combined together become this record. Okay, so in this case, partition key plus sort key combined together known as primary key. Okay, and guys, this is a very common and typical way we organize our data. Either you can use DynamoDB, same kind of almost data model we use in Cassandra also. Okay, okay, so also there again we use the word called primary key or partition key. And sort key is normally known as composite key, but logic wise, they are almost same. Okay, so this is similar kind of data model we use in Cassandra. Typically, DynamoDB is document oriented. Cassandra is column oriented. There's a different concept altogether, but I'm talking about more about data planning, organizing part, or data modeling. Okay, so this is also way Cassandra also used. For extra knowledge, I'm talking about Cassandra. Main topic is here is DynamoDB. Okay, this is what we can do. Now, now, one more word I just want to tell you here. According to this planning, okay, my customer ID into the order stored in the sorted order. And why they store in sorted order? So they can search in this customer ID very fast. So they store in customer 1, customer 2, customer 3, customer 4. They create this kind of sorted order they store. And technically in database world, if you store any attribute in sorted order, so in the future you can search by these names. Okay, because they're in sorted order, we can search very faster. So these are known as indexes. Okay, so technically in this case, whatever sort key you use, they intended to create an index for you. Okay, so you don't have to get extra index. Normally, guys, if you ever work on any other databases, you have to go and create extra indexes there. But here we don't have to create any index here. But there is one concept called secondary index. What is secondary index? We'll discuss after some time. But technically, when I use sort key, they make this particular ID become the index for you. And that means they store in the sorted order. That's called index technically. So we can search very fast. Okay. So like this. Now in this case, if I create this, new table is created. Let us create. If you see in overview, this is my table name. My person key is city. Sorted key is customer ID. That's all. Now, if I store my items, okay, and I create item, now these two keys compulsory. Why city? If I give Mumbai here, they create a separate person of Mumbai, separate space, a separate node. And all the Mumbai data they store in the same logs. If I propose a customer key, okay, so let me give you a customer name C1. So they stored the customer information in the sorted order. You don't have to do, they will manage everything for us. Okay, but after this, what attribute you want to store or what information is stored, that will be your choice. maybe this may be my name. This called let's say Jag. This is the remarks. Let's say okay. These are the extra information. That is the main information I want to store. So these are your main attributes, and these are the way you are going to organize your data. This is called data model. Okay. Now in this case, if I store one more time city, Mumbai, right now there's no error come up. Last time if you try to store same city or same email ID, they will fail. But this one they won't because this is a person. And let me store my second customer with the different details. Let's say the phone number. Now it means two cities Mumbai, internally they create a Mumbai partition and store all the information in the one area in one single partition. Okay, but as soon as create a different city altogether, suddenly with a customer, maybe customer ID, maybe anything. Okay, with mobile, for example. Okay, so in Delhi they create one more person for you. and they start storing this entire information and that parts. And now in this case, if you do query, in this one, they will give you two things: partition key and sorted key. Okay, now here I say I just go for Mumbai. Now guys are searching so faster. The data may be 10 GB, but Mumbai only contain 1 GB data, so they will only go to Mumbai space, Mumbai node, and they pick the data from the Mumbai. So they don't have to search between all the 10 GB data wherever you have Mumbai searching. So if you think, guys, now they don't have to search even Mumbai. They know in the only one location Mumbai is located. They go there and retrieve all the Mumbai information. So it's like a very very much faster speed they can search. Or even though anybody who know about searching, there's a concept called big O notation. So I can say big O1, constant time. They are always very constant in searching. What are the gross data size grow will be, how much they grow, I can say. Okay, searching would be again almost same speed, because we are showing entire Mumbai data in one area only. So there's no meaning of searching. Okay, now I hit enter, obviously output Mumbai come up. I can't see the speed here, but technically this is how it works. By Mumbai, if you're looking for some particular customer, so I can give my customer name for C2, for example. So now they only retrieve, now here they will go and search. So they go to Mumbai partition and look for C1, C2, C2 here. And because they're in sorted order, again, searching would be very faster. This concept called binary search speed or logarithmic speed. They will search for you. Okay. This data okay. So guys, again, it's all about organizing our data. That's called data model. Better you organize. How you organize, you have to first understand your requirement. What would be the future requirement? Okay. If you think your requirement something like this, the example I had taken over here, then this is the way you can organize your data by partition key and the sorted key. Intention is pretty simple. I want my search speed to be very faster, and that is one of the reasons why this guy is claiming this much requests per day they can handle. It's not because of the hardware or serverless. It's because of their data model also. So they're saying you should have to do proper data modeling. Then only you can get this kind of speed. Otherwise, you can't. Okay, so multiple things work together, then it become a final foolproof solution for us. Okay, so what are items? Main concept, primary partition key. I explained to very important concept. What capacity I explained to you. I need one more small class on DynamoDB where I explain some more concept, especially indexes, how to get extra indexes, and some more thing, GSI or LSI, how we create and what the use of this. It's based on this concept only, but in the next class, I will talk about this topic. Okay. So guys, we'll update, announce you soon. I need, because guys, if you see your agenda of your AWS developer track that we have given to you, if you see almost all the topic we have covered, main topic left was DynamoDB. Okay, that I am covering. So I need one more class on the DynamoDB, and we will conclude our developer track. Okay, so only DynamoDB topic was left. Otherwise, all other topic I already covered in our normal training of CSA. That time already I covered to you for you. So I need most probably one more class to cover the remaining topic. Okay, but I hope you understood these things. So maybe this topic I can again cover very quickly. Nothing technical here, but I just try to show you what is also happening behind the scenes, so you can have a proper idea what exactly they're doing. But DynamoDB, guys, we need one more class, so we cover the remaining portion of DynamoDB in the next class. Okay. So yes, Hers, DynamoDB is like MongoDB. Only main big difference is big difference is a managed service by AWS. MongoDB is not managed, not managed, I can say serverless service. Okay, so MongoDB is not serverless. We have to manage. by ourselves. It's a different tool for a different company altogether. DynamoDB is worked by AWS only. Yes, Kaustubh, you can use container also as a node. There's no meaning of foreign key here. Okay, we don't need this. Uh, Foreign key we need normally in our DBS world. We have a multiple table where where some information of our user I store in one table, other information store in other table, other information I need store in other table. Then to to retrieve all the information, we join it. There we normally use foreign key here because we're storing entire information of one record in one table. This code data is normalized, so there we don't need any foreign key. Okay, so in this kind of data structure or data model, Piyush, we don't need any foreign key. Huge difference on Manyar. Hadoop storage cluster is very different. DynamoDB is very different. Okay, Hadoop we use for data lake, big data, and other things. DynamoDB we use for this purpose the way I explained to you. If you know Hadoop, it mainly used for data lake purpose. Scan and query differences. If you want to search in all the data, where we use the scan. Okay, means if you want to retrieve the entire data of this person key and sort key, entire data. Okay, maybe I can use in this way, or maybe use in this way. Okay, if I search, entire data gonna come up. Okay, it's normally known as full search. But if you are looking for particular thing, particular item, okay, there we can use query. We never upload image and video in DynamoDB. And the best practice is we upload image and video in S3. And what is the URL where we store? That URL we store in DynamoDB. So we get one image attribute or image URL attribute. So we store object in S3 and the URL we upload here. So with the help of programming, we first contribute DynamoDB and ask, tell me the URL of my image. So DynamoDB tell the URL like a string, and that URL we use to retrieve the image from our S3. So this is how guys normally do it. Yes, Deepak, you can integrate with any language. So we have a different SDK available: Python, PHP, Java. Okay, so you can integrate. Or maybe you can use Boto 3 also. How to use Boto 3? In my last class, I explained all very detailed. So you can also use Boto 3 or Python to integrate with DynamoDB and access the information, read the information, read the information. You can do from Boto 3. What is serverless are, I think in my last class, I have explained you serverless in very detail, especially when I take the topic called Lambda. So I think I already discussed it there. I think guys, we have started sharing or we will start soon question practice for AWS examination. So we have already, I think, distributed form. We ask my team again if you haven't done yet. So anybody who are going for AWS examination, we will providing you a practice question set for practice. Oracle database, which database? Actually, Shubham, Oracle has a lot of different flavors of the products. But yeah, if you normally take, say only Oracle, normally we're talking about RDBMS kind of Oracle, normal SQL world kind of Oracle. But otherwise, Oracle has a lot of other products. They have some NoSQL also, data warehouse also, multiple other, uh, suite they have. So P, I don't know what message you are having. If you're having some concern, what you're writing here, server is not replying your message from 4 days. I don't know. There might be reason. So you can connect to your respective WhatsApp group, technical head, or maybe some of the technical volunteer, message them or put the mail in our official ID. So whatever concern would be, they will reply to you. Okay. Nikhil, what you asking about microservice? I'm not reading the entire question over here, but if you have this kind of plan of scale in, scale out based on CPU and memory utilization, something like this we have already discussed. Cloud watch alarm. Okay, so you can create a cloud watch alarm. They will help you. Okay, and the alarm that you can put in ECS cluster also, maybe in a load balancer also. Where you want to put, you can use. Okay. So answer is, your question is, maybe we can use Terraform. Answer yes, why not? If you know the concept, same concept we can use, find a Terraform module for this. Okay, for CloudWatch if it is available, and if it's not available by chance in Terraform, most probably they should be available. But if it's not available, you can use use the API of that particular resource, or maybe you can use local provisioner and call the local AWS CLI command. These are my other alternative, but just go and search in Terraform. Can we create a CloudWatch alarm? Obviously, they should have a resource for this. Okay, and create alarm for you. Okay, and obviously you have an alarm. You should have you have ECS resource also in Terraform, and ECS you will find some way to attach the alarm. Okay. What Nikhil, you asking multiple questions you have put here. I'm just reading, not reading entire one, but as RDS one, what you asking? One is task, third party tool using programming language. For RDS, okay, for RDS, they are a multiple different databases like MySQL, MariaDB, okay, or Postgres SQL. Every database has their own command for test connectivity. Okay, so in your programming language, they have a let's say for example, if we talk about Python. So in the Python, you have what I say connectivity tool. There's got DB Connect tools. Okay, so you have a driver for the Python or maybe Java. Use the driver for your respective databases, maybe MySQL or PostgreSQL, and that database has the command to check the connectivity or check the connectivity with databases, check the database there or not. Okay, so answer is yes, you can use any programming language, whatever you're comfortable on. Okay, and then you can use their respective command of respective databases to test their connectivity. Okay, connectivity in the terms of does this database available or not? Okay, something like this. So you can use. Yes, Chaitanya, we will do service mass. Right now, I'm busy in somewhere else. So after 2 months, maybe we'll come to training on service mass Istio. Training or maybe on the workshop. So how to check the health of RDS, Nikhil? Again, I told you already. It depends what you want to check as a health. If they're down or up, simple. Your connection string will check. So your respective driver will come up with their own, um, I can say, health check APIs come mostly in your databases. So just keep on checking the health on that particular API. Or use the connection string in your language to check your database is up or not. So I don't know health is which context, but normally when I say health, we mean to say does database is live or up or not, or mean to say it is not it been throttled yet. So database they have their own commands, or you can use your programming language also to check it. Or maybe because it's RDS, you can use CloudWatch to check it. If you're looking for resources throttling, right, for as a health check. So CloudWatch, we can set the alarm and they will send a notification and they will do something else, what else you want. Redis is fast and dynamic. Mukta, there's two different use cases. Redis we use for cache management on the top of your, or session management on the top of your web application. And DynamoDB you use for storing this kind of documents. So there's no meaning to compare which one is faster, right? So there's a different use case. Any plans? Splunk and Grafana, maybe Splunk Sandeep we might come up. So, Anu, what your topic you write here? I think this might be small for topic we have as a discussion perspective. Okay, so don't worry, I'll cover in this next class. Okay, these are in the developer tech. They have this topic as per discussion perspective. But these topics are mainly from AWS security track. So to go for security, these are the topic they cover there in the specialized program, right? But as a overall perspective, if you want, I will very quickly cover this topic in my next class. So that's all, guys. See you in the next class. Most probably, guys, next weekend we'll try to conclude the developer track. Okay, and that's all, guys. See you. Bye. Take care. All the best.